As if there's no questions, we're just going to get right back into Chapter 8. Section 8.1 is the only part of Chapter 8 that's going to be on this first test. When we get to Section 8.2 and 8.3, that's where we're really going to start to do true analysis of data. And I'm even going to make you guys think back to when you did that serial project, and then you're going to start to go, oh shit, if only I'd known this, I would have done that for this. So we're going to learn some kick-ass ways to analyze data. The reason we did that serial thing when we did it is just to let you guys figure out stuff on your own, just to go, what could we do? But now we're going to get into, well, here's set stuff that you could do for data. If you weren't here last time, we went over some definitions. Before I forget, anybody not get the practice test that came in after I gave it out? So last time we talked about population, we talked about sample. Somebody tell me real quick what a population is?
Amount of people?
It's not an amount. It's not an amount of people. It's not like a number, but it's the group that you want to say something about. And be careful the way you say that, because the group you actually study will be the sample. So the population is the group of things or people that you want to say something about. So if I wanted to say what the average gas price right now is in San Diego County, what would my population be? Gas stations in San Diego County. I like it, right? My sample would be, maybe I'll randomly pick 20 gas stations around San Diego County. You guys kind of with me there? And of course, I don't know if you guys know about Gas Buddy. Little app on your phone that tells you the cheapest gas closest to you. Because man, you go to Carmel Valley or something, you could pay $1 more than somewhere. Anyway, so I'm sorry if you live there, but if you live there, you should be able to afford it. Sure. So the population is the entire group that you want to say something about. I'm not going to write that. And the sample is, of course, the subset of that group, the collection of things that you pick that you're actually going to study, to do something with. All right, maybe. That's how statistics works. All right, you call a subgroup of people and say, who you got to vote for? I don't know. Well, shit, okay. Is there an election? Oh, God, okay. So that sample is a subgroup of the population. I like it. And we talked about, what's data? Information collected. I like it. So the way I think about it is like answers to the question you would ask. So if my interest was the average gas price, my population would be the gas stations, my sample would be the ones I pick, and my data would be actual gas prices at each gas station. I love it. How are we doing so far? It's not too bad? Right? Okay. Let me think. There was something else we talked about. Oh yeah, we have descriptive statistics, which is just visualizing the data that you get. And inferential statistics is where you actually analyze it and get averages and things. Okay, cool. Well, so I'm just trying to catch us back up. We did talk a little bit about what is a good sample, right? You guys are not bad people, but you would be a bad sample if I was trying to say something about all Grossmont students. So we talked about why you guys would be a bad sample. Cool. What is it we're always going for when we want to take a sample? What makes a good sample? What makes a good sample? Diversity. I like it. Right? And it's not necessarily that you control for it. You don't make sure that you get all these different little subgroups of people or things. But what you want, what's the real goal? Everything in your population. Well, that would be the population, but every element of the population has to have an equal chance to be in the sample. So if I picked you guys, then people that come to school later don't have a chance. People that aren't in my class don't have a chance. So there's a whole big part of the population that I'm not giving a chance to be in the sample, therefore it's not a good sample. I like it. So every element in the population has to have a chance to get into the sample for it to be a sample that I would trust. All right, Howie? Again, this is all stuff we talked about yesterday. Just want to catch everybody back up. So today we're going to get in a little bit more on some numbers, right? Makes sense, math class. We're going to get into some numbers. And what we're going to do first off, and what I normally use on the test or something is like actual data you guys gave me on the survey. So I'm going to give you some data from the survey. You can analyze yourselves. But the first thing we're going to talk about is these things called frequency distributions. And actually, we'll do this. I think yesterday, did we do stem and leaf? Yeah. All right, so let's do this. Let me do this. Instead of just coming up with a whole bunch of numbers, if you have your book, it's, let's do page 506, number 17. If you don't have your book, I'll put it up here. I guess it doesn't matter. Let's see. Actually, let's do number 31. Aha. I'll come up here someday. Yes, Panasonic, you can do a commercial while we wait. Panasonic, the future is now. All right, here we go. All right. So, here's the data. All right, can you guys see that data well? If you don't have the book, can you see that? This number 31 here, right? All right. So, if you could take a minute, if you weren't here yesterday, you might want to get with somebody else. But go ahead and take a minute and make a stem and leaf plot out of that data. Create a stem and leaf plot from that data. Or, like I sometimes tell my classes, draw a picture of a duck just to make me think that you're doing it. But do something. So make a stem and leaf plot out of that data. That's what I prefer you do. Yeah, we gotta take their word for it. Yeah, 25-year-old. I feel for them. I started teaching when I was 26, and I looked like I was 17. Students be like, "You're not the teacher, are you?"
Is that your finger but like frozen? This finger's
Well, there you go. Now you're noticing. Yeah, I could freeze it. So yeah, I did that just to freak you out, and I like the delayed freak out. That's good. So, which number are we now? Like 42 or something? You would just 30, you would put 0, 0, as many as there are. So you need to end up with as many entries as there are numbers. Does that make sense? Don't just put 1, 0, put all the zeros representing all the 30s. Because it's supposed to show you where most of the data is. So if you're cutting some out, it's not going to be an accurate representation.
And you're not sure?
Like yesterday.
No. Well, I'm going to show you one thing after you do it. Because that's what, us teachers do. Alright, how we doing? Are we doing okay? Just to make sure you guys are on the right track, what are you guys putting down here?
20s and 2, 3, 4,
4,
5,
5, 6. Any 70s? Alright, good. Phew.
45, 28, 29.
Alright. Who? What?
Oh, there's 2 8s. Like there's 2 28s.
So yeah, let's see now. 20s, what do we got? 20s, we got 25,
28.
28, 29. There's only one of each, right? No, there's 2 28. See that?
Yeah, there's 2 28s.
So it'll be 25, 28, 28, 29.
Yep.
I like it.
I keep this like
That's really strange. Now I know.
Whoa.
That was just so weird.
Sorry, my finger freaks you out.
It didn't get in my mind until I saw it more
Alright, let's see. You don't have to put them in order necessarily, but it's not a bad way to sort it. But you can actually just go straight through. What do we got for 30s? We got 38.
30.
We got 38. Well, did you guys put them in order? That'd be even better.
Yeah.
What do we got? We got 130.
0,
2 zeros. Okay.
1,
1,
2.
2.
That's as far as I got.
Oh, okay.
4, 5, 6, 7, 8.
There's a 4.
Yes.
4, 5, 6, 7,
7,
8.
8.
One of each.
Yes.
And no 39-year-olds? No? There's a 35 right there.
There's 2 37.
2 37s?
Yes.
All right, thank you, sir. 37 there.
Yeah.
37 there. I like it. Don't freak out right now. I'm trying to build up motivation for what I'm going to show you that TI calculator can do. What about 40s? What do we got?
4, 2.
Do we have a 40? There's a 40. And a 41? Yep. Just one 41? Yep. And then 42s. Let's see. 1, 2, 4. 3, 4. 4 42s. 43. Snow.
44.
44. 2 of those. 2 44s. Let's see. 45s. No. 46, one of them. No, there's a 45. Thank you. So 45, 46,
47.
47, and then 2 48s, it looks like. Yeah. 47, 2 48s, and a 49. All right. And then 50s. We got a 50, 2 51s. 2 51s. And 2 59s. That's interesting. All right. And then 60s, 62, 2 63s, 4 63s. Let's see. 62, 3 63s. And 2 66s. So we got 4, 4, 8, 10. So we got 4 here. 10 there, 14, 18, 22, 26, 28, 33, 36, 39. Sample of 40 high school teachers. Damn, we missed one somewhere. We'll be all right. So let me show you this. Now that I kind of made you suffer through that. Can somebody, while I'm doing this, does anybody see what I missed there? Or did I just miscount? 4, 8, 12, 14, 16, 28, 32, 37. Now I'm getting too many. Shit. Do I know how to count? 4, 8, 12, 14, 18, 20, 24, 28, 33, 36, 30, I get 39. So let me show you this. There's one reason why we want you to have that CI calculator. It costs enough money. You should be able to help us with this. Let that computer warm up.
Under 5, there's 4, isn't there? 4?
Yeah, cool. Thank you. Oh, thank you. So make this 54. All right. So even from what we've done so far, can you guys tell me where most of the data is? In the 40s. There's most people are age 40. And do you see how it kind of starts low, goes high, and comes back low again? It kind of does this kind of thing, and that's what's called a bell curve. That's called in statistics, it's called a normal curve. And the reason it's called a normal, you guys have heard of the bell curve, right? When you say curve your grades, I look at where that is, and then you pick up the curve and you move it somewhere. You're like, oh, the highest grade was 60? Well, let me pick that up, bam! And then I just see where everybody falls. I do it a little bit differently, but that's basically what it means to curve grades. But the reason it's called a normal curve is, would you expect to see somebody who is, for you guys, that's the highest. Would you expect to see somebody who is 7'8" when you walk out the door? Would you expect to see somebody who is 3'9"? No. You would expect to see somebody close to the average height, wouldn't you? So this is how things occur normally. It's one reason why we call it the normal curve. If everything happens normally, then there should be high amounts of people in here, and then less and less people out here. Less tall people, less short people. Good. So grades, there should be a lot of people near the average, and then there should be a few people that got really low grades and a few people that got really high grades. That's what should happen on average. Doesn't always happen. All right. How are we doing there? Are we decent? Okay. Okay. So here's the next level. So that's the stem and leaf plot, and I think I told you guys you put a little key. So you say like 2.5 means 25. Because what else could this mean? 2.5. What could that mean? 2.5. It could even mean 250. You just got to give a key so I know what the heck your thing means. All right. I like it. Okay. So this is actually still what we did yesterday. Let me show you, though, how the graphing calculator helps. And I probably should show people at home what's happening. What's happening? So I'm not going to put all this data in here. But this is really kind of cool. This is one reason why this thing costs as much as it does. So see this button labeled stat? Let me make that bigger. Bam! Alright. So there's a button right here labeled stat. It seems to be a really good button for doing statistics. There's also a button called math. If you have one, you might as well push it, play with it, see what the hell's in there. But if you look at her stats, here's when you want to do statistics, you're going to have a long list of data that you want to do stuff to, right? You want to find percentages that made higher than 90, or you want to find the average of the data. So the first thing I have to be able to do is actually put the data into the calculator so it knows what the hell to work with. So if I just hit edit, I can put data in here. Now if you're trying this along with me, you might have stuff in your list. You would go up, hit clear, enter, and then all the data that's in there is gone. Just don't hit delete, because then the actual list just goes away. And I'll show you what to do after that. But if you just put, I'm just going to start putting the first few, 63, 48, 42, 42. All right, this is enough. Just imagine I put it all in there. One basic thing this does is if you hit stat, sort, you can sort the data right there. Number 2. Why do you think there's 2 sorts? What does sort A mean versus what does sort D mean?
Ascending.
Ascending, descending. I like it. Right. So I'm going to sort it ascending from smallest to biggest. Bam. And then I can have to tell it what list I want to do. Now, where did I put my data? Which list did I put my data in? List 1. So if I tell it I want it to do list 1, it's right there. So I just hit second 1 and tell it I want you to sort list 1. A little anticlimactic. It just says done. But if you go back in, stat, edit, now the numbers are in order, this kind of thing would be a hell of a lot easier, right? Okay, cool. So on the day of the test, I will have some graphing calculators with me that I'll let you borrow if you don't have one. So if you don't have one, you want to get one. Okay. Now, obviously, this thing can do a whole lot more, and we'll get into what else this can do statistically when we get into section A2 and section A3. I like it. I like it. I like it. Okay. You guys decent with what just happened? You don't have to. You can still do this, but you can see how easy it is to miss. It's almost good that that happens, because it so sucks when you get to the end, you like missed 1. Oh my God. Or there's 1 too many. Oh shit. So this will help you not do that. Okay. So coming back to this data. Now that we've got this here, let's see if you guys get this. If you take statistics, you're going to get into a little bit deeper. Basically, everything we do here, you're going to get deeper into when you actually take a statistics course. This is just sort of a broad overview. So, I'm skipping a few little math steps here, but I'm going to give you something I normally have my students calculate. Let me just see what you think about this. So I'm going to do something with this data differently. I'm going to group this data together. And let me think for a second. Let's see. Okay. So let me see what you guys think about this. You can do it, Jeff. Did you do it? No, you're horrible. You did horribly. Let's see. Okay. No. There you go. That should be fine. This will be given to you. The homework gives this to you also. I don't know if you've looked at the homework with the examples, but they give you these classes. If you take statistics, I actually talk about how to construct these classes. If I said how wide is each class, how far is it from that point to that point? 9. So each class is 9 wide. Right? If you go 25 to 33, how many data points are there? 25, 26, 27, 28, 29, 30, 31, 32. Holy shit, there's 9. So that's another way to say it's the width of each class is 9. Let me stop there for a second. Is that cool? Okay. If I said, what's the frequency, Kenneth? No, what's the frequency for each class? What does your gut tell you that might mean related to the data? So I want the class from 25 to 33. What's this, ages? What was this? Yeah, 25 to 33 years old. So how would I figure out what to put next to that? The frequency of that. So frequency. Go ahead, sir.
Is it like how often?
Yeah, how frequently does a data point show up between those two? So how many data points would actually fall in this class? How many data points, how many ages fall in there? Well, 25 does. 28, 28, 29, 30, 30, 31, 32. Don't they all fall in there? 34, that's in the next class. Do you guys see that? So frequency is really how frequently a data point shows up in there. So how many data points did I catch? 8. So I put 8 there. Bam. I like it. So finish that out. Now please, hopefully nobody's putting 8 everywhere because you think that I did 33 minus 25 and got 8. You guys with me? I mean, sometimes I'll have somebody think that, and then what good would that be? Everything in the world would be all the same. It's how many numbers fall in there. So what would this one be?
12.
Yeah, it looks like 12, right? From here to there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool, I like it. There are 12 data points that fall in there. I love it. Cool. 43 to 51. 11? 3? 6. And then if I add these, what should they add to be?
40.
They better be 40. So it's a nice quick check. Let's make sure we did it right. 9, 20, 30, 40. Thank God. Yay. It's just a nice little check. Now, I could make you guys take the next step, but there's a few reasons I don't. I don't like what the book does with this. There's a little more detail to it, and this is as far as I'm going to ask you to do. If you look on the, I know I asked you to put this away, but you don't have to get them out right now, but the next to last problem on the practice test is this histogram. But right before that is what I ask you. I give you grades on quiz 1 from last semester, and I ask you to do this. Make a frequency distribution. So that's as far as I'm going to ask you to go. Okay. But if I wanted to, I could certainly kind of graph this, and it would end up looking like this, this kind of image. No. Oh, there. Right? Can you guys imagine that? I don't like the way they did their scale. Their scale is kind of silly. Those are numbers. It should be 31 to something, and there's a little more detail in there that you'll get into if you take statistics. But I can live with that for right now. So I could certainly make a picture out of that pretty easily. I mean, why is that bar on 41 to 45 so tall? What do you think that means? And this is, by the way, this is starting salaries in thousands of dollars for college graduates. Right? So these people are like, what the hell are you doing? It's not bad. So why is this one so, what does this mean? What does this bar right here, what does this 41 to 45 bar mean? Yeah, how many people made what? How many people are in this bar? Yeah, good. About almost like 340,000. I'm sorry, 340. The money's in thousands. So there's about 340 people, college graduates, that did what? What do those 340 people do? They You guys sound anemic. Did you have breakfast? 340,000, or like, I guess it's like 320,000. I can't look at that right. 320 people made between $41,000 and $45,000 to start off with, which is, which is pretty good. Shit. I was like, whoa. Let me stop there for a second. Is that decent? You guys see how to read that? So I'm not going to make you make one of these, but I am going to ask you to read this. What's up?
That was my question. If you want this to me.
No. There's a little bit more detail that I would want. So I don't agree with the way the book does this. It does it a little too simply. So when you get to stats, you're going to have a little more detail to put into it. But this is fine as far as just how to read it. And there's an example problem on the practice test. I give you one that's created, and then I ask you questions about it. So that's the kind of question I would ask you, right? I like it. So that's all about shampoo and how long it lasts. For guys, it can last us for a long time. Yep.
So a class is the range you're studying? Like, are you grouping
Yeah,
into?
and again, it's this is sort of like an overview. There are several ideas that go into how wide the class is going to be. Why did I make it this wide? It was based on how far the data went from 25 to 66. And I wanted to have 5 classes, so I did some math and figured out how wide they'd have to be to go that far. So in statistics, you're going to get a little deeper into the math that's behind it, and the considerations in how many classes do you want. So there is math behind these numbers, but for right now, it's just the idea that we want to explore, right? The idea of the statistics that we want to explore. Okay, maybe. So for some of you guys, I love this. Maybe some of you guys are quiet because this is too easy. And sometimes when I ask too easy of a question, you're like, I don't want to answer that question. Give me a hard one, man. It's not showing off if I answer that question. Hopefully that's what was happening earlier, because this shouldn't be a horribly hard thing. It shouldn't be. Okay. And the only other thing that I want to talk about in section 8.1, let's see, where are you?